Well, looky here, it's a 3090. Yeah, I've heard it from you guys. I went ahead and blew my wallet wide open and acquired a 3090. We're going to put it to the test tonight. We've got it next to a stack of 4060s I got to get rid of to pay for the 3090 and all this crazy stuff that I'm doing in here. But there we go, 3090. So let's look at the lab tonight. We've got a 3090, the 4500. 20 gigs, a crazy Tesla M40, 24 gigs, and I guarantee you back in there is a 4060 Ti with 16 gigs of VRAM. We're going to put these guys to the test on the new Llama 3.1 8B model tonight and see what we can do without trying to burn down the house. So with it all, let's get to the lab. Welcome back to the lab, robots. We've got two big things this week. The new Llama 3.1 models were released. The 8B, the 70B, and the 405B. Tonight we're going to do some focus around the 8B model. As a reminder, if you haven't paid attention, the 3.1 models upped the context size all the way to 128K. So if you are going to run this in default mode, it's going to cost you a lot more VRAM. So much VRAM, in fact, that you are not going to be able to fit the 8B on a single 16 gig card, and I will show you why. I'll throw this down into the description just so that you guys can see this, but if you scroll all the way down, we have the memory requirements up at the top. So the 8B model, depending on what quant and what precision of the weight you're basically running, ends up how much memory you think that you're going to be able to use. So you can use this as a judge of what this is going to cost. Now, on top of that, we want to talk about the actual KV cache and how context size affects your KV cache. You can look into the KV cache a little bit more, but if you are running the previous models of Llama 3, it capped out at about 8K. 3.1 is all the way up to 128K. So if you're running the 8B model, just your KV cache is probably going to be up around the 15 or 16 gig mark. So you're not going to be able to fit this on a single 16 gig card. In between that, and depending on what quant level you are actually running. Alright, so with that in mind, tonight we're going to focus mainly on a 32K context. Why? Because that will fit on a single 16 gig card. And then that brings us back to our contenders for tonight that you guys already saw. We are going to put up an old Tesla M40 24 gig card from 2015 up against an NVIDIA 4060 Ti that's got about 16 gigs of RAM, up against an A4500, which has got 20 gigs of RAM, and then bringing in that final new contender of ours, the bold, power-sucking 3090. So we're going to bring in at the end, this 3090 that we just acquired and put it to the work on here. Let's go ahead and get started. I think we all know that the M40 below is going to be the one that is probably going to be the slowest, but this results might surprise you on a model of this size. So I'm just going to go double check the model and we're going to get the context size. Yep, we're set at 32K. This should run about 14 gigs plus the model at a Q8 quant. So if we're going to do this, let's just go ahead and use the largest quant that we possibly can. So in a flat file, right, this model, the Meta Llama 3.1 8B instruct, Q8 flat file, about 8.54 gigs, and we'll use this quant because we can pretty much fill an entire 16 gig card, and that is the card with the least amount of VRAM that we have available to us today. Today we are going to be using the bench node. Just to go back over so people understand what the bench node is, it's a Core i9-9820 at 3.3 gigahertz. Runs in a C9X299 PGF logic board. It's got 128 gigs of RAM in it. It's got a couple of 128 gig SSDs that it uses for boot, and then a 1 terabyte NVMe drive that it actually stores all the models on. It can handle 4 PCIe 3.0 up to 16x, but you can look at the different modes here depending on how you're running it. You might not get all the way up to 6x across all four of them, but you might get all the way up to 8 with no problem. It has 2.5 gigabit networking, 850 watt power supply, runs in Ubuntu 2304. It's a part of a Kubernetes cluster that I'm running it in. The nodes without GPUs cost me about $926 to build. Today we are using a 3090, an A4500, a 4060 Ti with 16 gigs of VRAM, and a Tesla M40 with 24 gigabytes of VRAM. So let's just go ahead and jump right into the testing, see if we can make this fairly quick. Let's set up our environment. We're going to go ahead and start with just the M40. Or excuse me, the M40 was 3. Let's patch this GPU deployment. And what this does, just so everyone knows behind the scenes while this is running, is this actually reaches out and patches the deployment for LocalAI on my Kubernetes cluster to tell it what GPUs are available to it through the environment variable of NVIDIA _ visible _ devices. So this is just doing that behind the scenes to basically tell it what tell that container what GPUs it has available to use. All right, so we've got nothing but the M40 here. Let's go ahead and switch over and grab our 8B and Q8. Remember, this is going to be at 32K context because that's what fits best on the 4060. You can always do more if you have VRAM available to you. If you wanted to run the full 128 context, it's probably going to require at least 4 16 gig cards, or do the math, around 40 to 48 gigabytes of VRAM to run that large of a context. Just keep that in mind. All right, so we're going to name this one Llama 3.1 Q8. Actually, let's add 8B on there. 8B, Q8, M40, and 32K context. I'm going to grab that name so we have it for the further test after this one. As normal, we're going to skip the first result because that's the unloaded memory. This is, you can watch it over here, how long it takes to load up the first time. It's just that the model isn't loaded into memory yet, and it kind of throws off the graphs or makes them less granular. So I normally skip the first result. We'll do our normal 21 runs here. And let's get a watch what you guys expect out of Llama 3.1 8B at 32 context and a Q8 quant for a Tesla M40 from 2015. Now's your chance to throw it out. Let's get this started. While that starts to load up, we'll go over off to the right hand side. On the bottom right hand side, this is NV top. This is going to be a live metric of those GPUs, and we can see that it's only using the M40 off to the side there. Up at the top right, this is Prometheus and Grafana. This is watching the GPUs. The metrics on this one will lag behind because it is a separate system that is scraping these metrics off of the nodes in Kubernetes. So just keep that in mind. It's going to lag behind over there. So how does this feel over here? Have you guys been watching this? How does that feel? First one is coming back at just over 18 tokens a second. It's going to settle down into that. I want you also to pay attention off to the right just how much power this card is taking. And let's make that easier, as I forgot to set this up. And we'll go over to GPU 3. So now this is just looking at that Tesla M40. All right, let's let this test run, and you guys can watch it, and we'll come back to it at the end. Hey, you go, old Tesla M40 from 2015. Is anyone else seriously impressed that this thing is pulling off anywhere from what looks to be 12 or so tokens per second? Even though it's eating, if you guys watched over there, about max of about 190 watts. So it's pretty power hungry, and it's got an external fan that isn't even included in that wattage. It's just driven off the logic board. So that's actually fairly impressive to me, but let's go ahead and take a look at the full report. Just make sure our data is there. We'll jump over and grab that report. 3.1. Take a look at the raw data. I just scan over it to make sure all the rows are intact. All right, prompt evaluation time. There you guys go, flatlined out. Let's look at evaluation time. Total time should basically mirror that. Prompt token evaluated, it should be 100 across the board, as remember our test runs a static 100 token prompt, or depending on the tokenizer that the model uses, around 100 tokens, but in this case it was 100 tokens exactly across the board. There is the completion tokens for you guys, and total tokens. Completion tokens are basically going to mimic how long of an answer it gave you. And remember, any model is not going to give you the exact same answer back every single time. Prompt tokens per second. About 100 or so less than that incoming prompt tokens, and what everyone wants is evaluation tokens per second. Not bad. Not bad, honestly. Not bad at all. Okay, let's keep going with our test, and let's bring in the next contender, which is going to be the 4060 Ti 16 gigs of VRAM, and let's see how that does with the same exact model. So let's go ahead and set this to 0 to get the 4060, and we'll patch that deployment. And it should come back with just the 4060 here. And there we go. We'll change this to, say, 4060. And make sure we grab the right model. Back to the Q8 Quant. And then we'll do the same thing, 21. And make sure to skip our results so I don't forget that as the test is running. Now, what's your guys' guess? So we saw that M40, right, from 2015. Here's a consumer grade, pretty much current GPU. What do you think this is going to do with Llama 3.1 8B compared to that M40? Take your guess now. All right, let's go for this, and we'll grab the right GPU over here so that you guys can see all the metrics on this one. And again, pay attention to the power consumption of these cards, because that is something you should consider when you're building these labs out for yourself, is price versus power versus speed, so to speak, that you can get out of it. And there it goes. 4060 cruising right along, seems pretty darn fast to me. We'll wait for the metrics in Grafana to catch up and let you guys get a feel for what this 4060 does. First one back at 23. And let's go ahead and speed this up, and you guys can wait for the metrics to catch up. Okay, this 4060 at the end here was pumping out about 22 tokens per second, and if you were paying attention, at about max of about 95 watts or so. So it's basically doubling that M40 at half its wattage. Interesting, right? So let's go ahead and produce that report and go double check our data. And 40, 4060. Show the raw data, just double check, make sure it looks okay. All right, prompt evaluation time. There you guys go. Evaluation time. Peaking up at 27,000. Total time should mimic that plus the prompt time. Prompt tokens evaluated, again, should be a solid 100 across all of our runs. Completion tokens is basically going to mimic the length of the answer that it gives you back. Total tokens is going to mirror that. Prompt tokens per second. Whew, cruising right along there. And evaluation tokens per second, which everyone wants to see. Averaging, again, about 22, so basically double what we were seeing for that M40. And remember, we were seeing a max, of around 95 watts or so on both of our data screens over there. That's pretty darn good. These little 4060s are good cards. Okay, so let's continue with our testing, right, and bring in our absolute next contender. These are my daily go-to cards, which are A4500s with 20 gigabytes of VRAM. Let's go ahead and set up our environment again. So this is going to be GPU number 1. So let's go ahead and patch that deployment. Wait for it to restart. And while that restarts, I'll switch our dashboard over here so that we're looking at the NVIDIA A4500. All right, let's make sure we get the right model. Q8 Quant of 8B. Set up our testing name. We'll call this one A4500. Skip the first result. We're going to do 21 runs, and just remember, this is just a static 100 token that I'm sending over and over and over, in case you haven't been at the channel before. And if you haven't, welcome. All right, let's get this one going. Anyone guessing how well the A4500 is going to perform versus the 4060, and what kind of power usage it's going to use during that time? Let's get it started. Should be loading up, and we should see it use GPU 1 over here. And this is already set to GPU 1. Remember, these metrics will lag behind. And in case you've been paying attention, it's been using about 14 gigabytes VRAM total for 32K context. And here it goes on the A4500. Just pretty much flying right along. And just to get a start, if I look over there, using about 180 watts there, I saw a peak at 192. Whew. Okay, let's let this test run, and I'll come back when it's over. Whew. Okay, yeah, there's the A4500. It looks like it ended up averaging about right at 33 tokens per second at the end. And if you were paying attention, maybe about 190 watts, so about equal to that old M40 as far as power usage goes. But again, literally 33 tokens per second versus what we were seeing, about 12 tokens per second out of that M40. So tokens per second to power usage is pretty darn good on the A4500s. Let's go ahead and produce our report and go check our data, make sure it all looks good. Llama 3, 4060, A4500. Let's just check the raw data. Always got to make sure my testing platform is working. All right. Here's the prompt evaluation time for you guys to check out. Let's take a look at the actual evaluation time. And the total time for you guys to look at. Prompt tokens evaluated, again, should be a static 100 tokens across the board. And the completion tokens basically mimicking the length of the responses that we're getting back. And the total token should look pretty much just like that. All right, prompt tokens per second. And evaluation tokens per second. Look at that, in between 32 and 35 tokens per second at 195 watts. Just let me write that down for later. 32 TPS. Okay. All right, so here's that moment that you've all probably been waiting for, and my wife would probably like to kill me over when just a random video card shows up in the mail. But we have acquired a 3090 from our home lab sales on Reddit, and specifically from a user iShop Stables. He made me a deal that I couldn't refuse, so we went there and we got this 3090 for the lab to do some testing with. So let's hop over and bring that to life. So that's going to be ID number 2 for us. So let's go ahead and patch that deployment, let it restart, and bring back that 3090. All right, we're back and we've got nothing but the 3090 there. Let's go ahead and set up our report name. Call it 3090. We'll skip the first result and make sure we get the correct model. Act like I've done this before. All right. Same exact model, same exact test that we have run. Anyone have any predictions for the 3090 versus anything that we've seen before? And any predictions just how much power the 3090 is going to take during this? All right, we're all set up. Let's go ahead and start the test. We should see it load up on GPU 2 over here, and let's make sure we get it selected up at the top here. Loading up about 14 gigs, just over 14 gigs in VRAM, and there it goes. Here's the 3090 24 gig model running Llama 3.1 8B Q8 Quant and 32K context. Really flying by. Really flying by. Pay attention to how much power it's going to use over there, because we're also taking a look at that during all these tests tonight. It's really cranking right along. Over 300 watts. All right, let's go into fast forward mode, and I'll come back when this is all done, because just to make sure, I should go get a fire extinguisher. Just kidding, it's not going to burn anything down, but it's always good to have one by. All right, here we go. Whew. Okay, so it's definitely the king on the channel so far as tokens per second and probably just straight flat out speed, but it came at a cost. That was also 300 to 330 plus watts I saw at peaks. Well, let's go ahead and generate this report and check our data like we should. $60, Q8, A4500, 3090. Well, show the raw data real quick. Looks good. Now let's take a quick look. Prompt evaluation time. Evaluation time. These are quick cards, really quick, no doubt. I agree with absolutely everyone. These are very good cards to choose. The total time. Prompt tokens evaluated, straight 100, as we would expect. Completion tokens. Remember, that's basically just going to mimic the length of the responses it was giving you. Total tokens is going to mirror that. Prompt tokens per second. Yeah, just flying even on the input, right? Evaluation tokens per second. All right, so we're averaging, I'm going to give it just over 40 to 41 tokens per second, but at 300 to 355 or 335 watts or so. 40 tokens per second. That's pretty good. That's pretty good. All right, with that, let's go ahead and bring all of this data together and see how much money we were burning in GPU costs and power. All right, report management. Okay, we'll select the M40. The 4060. The 4500s and the 3090. We'll turn this into Llama 3.1 AB Q8 32K Showdown. And combine the files and jump over and let's go take a look at it. Right there. All right. Okay. For the sakes of this report, and let's go ahead and make this quite a bit bigger for everyone. The M40 is going to be in blue. The 4060 is going to be in orange. The A4500 is going to be in green. And the 3090 is going to be in red. Alright, so we can see how the M40 really throws off this chart, right? So we've got prompt evaluation time incoming, M40 up at the top, and then almost exactly what we would expect. The 4060, the 4500 down here in green, and then the 3090 in red. Let's hop over to evaluation time. Just as you would expect, right? Here's that 2015 M40, which by the way was holding its own quite well. Here's that consumer grade 4060 card. In the green is the A4500, and then the high powered gaming card, the 3090, down here at the bottom. All right, the total time should mimic that really. Prompt tokens evaluated across all of these tests was 100 exactly. Completion tokens, it's going to be a bit over there or over the board because remember this mimics the length of the response that it's giving you back. Total tokens is basically going to be a mirror of the response. Prompt tokens per second. This is going to be, yeah, the M40 way down here. And then the 4060, the A4500, and the 3090. And let's hit what everyone is waiting for, right? Okay, so this is going to show you, remember, the basic speed that everyone talks about when they're comparing these cards or comparing different models. And this will actually show you what kind of speed that you can get for what kind of cost. So here we go. Evaluation tokens per second. We've got the M40 down at the bottom, the blue line. Remember, this was hitting about 12 tokens per second at roughly 140 to 190 watts while it was doing it. Not bad for a card from 2015. If you actually felt it at the beginning when we started this test, it was perfectly acceptable to work with. Now the 4060, this doubled our speed basically, right, from that M40, but it did it at 70 to 95 watts. So 22 tokens per second at about half the power of the M40. Not bad. The M40s are about $80 a piece or so off eBay. The 4060s, even if you buy them brand new at 16 gigs, these are about 450 bucks a piece. The A4500 that is up next, we were averaging about 32 tokens per second at the end, and it was pulling someplace in between 170 to 195 watts. So it's double the wattage of the 4060, but it's also a pretty exponential increase, right? So 22 tokens per second to 32 tokens per second. These A4500s, they haven't really come down in price much, but they were about 600 to 900 bucks on eBay over the last 6 to 7 months. You can always reach out to the sellers and make an offer on it. That's what I did to get most of mine for at least a little bit cheaper. Good cards, low power usage for the tokens per second that you get out of them. Not as low as the 4060s, but you get pretty good performance out of them. Now, up to the beasts, right? These 3090s. This was pretty impressive. We took down and we were looking at about 40 tokens per second. That's basically probably the fastest thing that I've tested in my lab so far. And it was doing it at about 300 to 335 watts. So also quite a big increase, another 100 to 130 plus watts over the A4500 that was getting about 32 tokens per second. The 3090s have gotten much more reasonable in cost, at least to me, and they've come down in the $600 to $800 range, whereas they used to be, like, say, more expensive than the A4500s. So they're a good value for what they are, but they're really big and they suck a lot of power. So you're going to have to remember that when you're building the system, especially if you're building multi-GPU systems, or if you're trying to fit these things into smaller cases, right? The same thing with the M40. The M40 is a very large frame video card and takes up a ton of space. It's got passive cooling, which means you need to supply your own cooling system for it. So take that into account when you're building these systems. The 4060s are super small, super light on power, and will fit in basically anything because they're so small. The A44 or A4500s are actually a reasonable size. They're much larger than the 4060s, but they can still stack into server cabinets very well, or large cases very easily. They do have a side fan, so you still want to be careful like that. The 3090, remember, is larger than 2 spaces wide, so it's going to take up quite a bit of space. All right, I hope everyone learned something. This was a pretty good showdown in between 4 cards of basically different generations and different speeds and different power consumptions. Let me know if you learned anything from it. Hopefully you enjoyed seeing Llama 3.1 8B in action. We'll do 7DB in some different videos and go from there. All right, buy yourself a pizza, buy your AI a pizza. Just make everyone happy. Hope you guys enjoy your week.